Okay, so now I'm going to start thinking algebraically. So rather than having to just keep working out different volumes and trying to see which is the largest, I'll try and come up with a sort of a general rule, a general formula. So what is fixed? Well, we're starting, for this task anyway, with a 20 centimetre square piece of paper. Obviously, you can investigate this further and try different sized starting bits of paper. You could maybe try a rectangle rather than a square. And then what have we been able to decide? Well, we have been varying the size of the square we cut off each corner. So that's our variable in this case. That's what we've been able to control. So that I'm going to call x. So then what have my dimensions been? Well, when that box gets folded up, x becomes the height of the box. So one of my dimensions is x. And then what about the other sides? Because they're both the same as each other. Those two sides become those two sides. Well, if I'm starting with 20 and I'm taking x away from each end, then that dimension is going to be 20 subtract 2x, and so is that one. So the volume is going to be x multiplied by 20 minus 2x multiplied by 20 minus 2x. Okay, and then what you really want to do to move on to the next bit is expand those brackets out. And how I would tackle that, I would actually probably expand those together, so using FOIL or grid method, however you prefer. And then once I'd expanded that out, and that would give me a quadratic, then multiply each term through by x. But you can have a play around with that.